All right, I'm just going in order. The first one that you mentioned was 4b. So it asks you to find the second derivative, and they gave you the first derivative. So the second derivative, you're just taking the derivative again, and the negative 1/4 is a constant, so you'd bring that down, and then you take the derivative of h, and it's not going to be 1 because the independent variable is time. So it's not 1, it's going to be dh dt. And then minus sign, the derivative of 27 is just 0. So that would be the second derivative. And then the dh dt right here is the same thing as this, right? So you could take this whole thing and plug it in for dh dt. So you have negative 1/4, and then dh dt is negative 1/4 h minus 27. From there, you could simplify a little bit because negative 1/4 and negative 1/4 would be 1/16. Okay. And then in the question, that's you emailing me right now. Within the question, they tell you that h is always greater than 27. So the temperature of the potato is function h, and the temperature of the potato is always greater than 27. So if you had read before, h is the temperature of the potato, and then it also says that it's always greater than 27. So that means if h is always greater than 27, think about what the sign of that's going to be. If h is always greater than 27, then that's going to always be positive, and this is positive as well. So that means that the second derivative is going to be positive. So you can write something like, since h is greater than 27, the second derivative is going to be positive, and that means h is concave up. H is concave up because the second derivative is positive. And this is something we did not spend a lot of time talking about, but there's a great visual that you can see. So you wrote the equation of a tangent line in part A, right? It points you back. Is your answer in part A an overestimate or an underestimate? If you know that H is concave up and you wrote the equation of a tangent line, anywhere you draw that tangent line, it's going to be below the function because the function is concave up. So I'll just probably jump to the rubric now. So part A, you have that equation. And because the tangent line is always under the actual function, the tangent line is going to underestimate the actual value because it's below the function. And I think this is only 1 point. So you can see the second derivative, negative 1/4 dh dt, and then they plugged it in like we did, and they got that answer. They said h is greater than 27 for t greater than 0. I didn't write that part. So the second derivative is greater than 0 for t greater than 0. Basically just saying the second derivative is always positive. Therefore, the graph is concave up, and so the answer in part A is an underestimate. That was all they needed to see. But really, I think it's just all in this visual. You have concave up. That means a tangent line is going to always be underneath. So using the tangent line to approximate a y value, you get a number that's smaller than the one that's actually on the function. So you can let me know if you have questions about that. Let me stop here.